Hello everyone, my name is Darius Świerat, and today I'm going to tell you about our femtosecond lasers and about micromachining, something that we very much like to do. To start with, a couple of words about Fluence. So Fluence is a femtosecond laser company with unique expertise in building fiber lasers. So our development starts from as early as from 2003, and we developed our products, developing fiber lasers, high power fiber lasers for micromachining, but also for other applications like microscopy. So our headquarters is in Warsaw, but also recently we opened a new application facility in Wrocław. So in Wrocław we have this micromachining station where we can test different applications using different methods like ablation cutting and much more. And also it's a place where we can characterize what we've done and show to our customers what can be performed, what can be done with femtosecond lasers. So something very unique about Fluence is our femtosecond oscillator. So our femtosecond laser is built in all PM fiber technology, where we don't use CSAM component, and thanks to that, it is very reliable, very robust. So like you see here, we tested from like a vast range of temperatures, either in the field, but also in the lab. For example, in environmental chamber that we have within the company, we cycle the temperature from -10 to +40 degrees as it's operating, just to show to people that the most important component of the ultra-fast laser, which is the oscillator, it's very stable and it's very reliable, right? So this is the most important thing in ultra-fast laser that exists. But we don't stop on the oscillator itself. We also have a broader range of products, right? So we do have oscillator, which is giving around 20 milliwatts of average power, and we have amplified oscillator like halide, which provides more power, 2 watts of average power, and this is mainly used for 2-photon microscopy and 2-photon polymerization. And we have powerful lasers that are the main topic of this presentation, which is Jasper and Jasper Flex. And Jasper is in particular interesting today because this is the main laser that it's can be used for micromachining because of its high power and very good parameters that are very useful for micromachining. So when talking about micromachining and in general about laser processing, there are different methods that can be used, right? So you can use femtosecond laser for something called laser scribing. For example, in this case, it was a semiconductor. If you want to cut it and then nib it, it's a very useful tool to have. You can use femtosecond laser for something called cold ablation. So you shine with a laser on a surface of a material, and the femtosecond pulse, because it's so short and so powerful, it caused this microcolumbus explosions that's caused this ablation process. But what's most important, this process doesn't affect the surrounding material when it comes to heat. You can have also something called rear side ablation. So this is a method that is used with transparent materials where you don't want to have a tapper. You want to focus the beam on the bottom side of your machined material, and gives you advantage of some extra precision. You can use femtosecond laser and form a bezel beam to be able to cut glass very quickly and very fast, for example, screens of smartphones. These are cut very often with this method. And also there is a method of cutting glass, which is called laser-assisted chemical etching. And this is very interesting. It's almost like as if doing subtractive 3D printing. So you first shine the laser on a point in 3D inside your glass or on the surface, and then you put it inside etching bath so that it can be etched into places where you used your laser to shine, to illuminate the sample. And then you can obtain very nice optical finish, so very good quality. And this is probably the most precise method to use, so that if you want to avoid this post-processing after using your femtosecond laser, this is a good method to go. If you want to go for speed, it's certainly better to use this bezel beam cutting. And if you want to do some low cost and effective and precise works, then cold ablation is probably also like very interesting thing to get. And especially that those three methods, they can be used mainly with glass. Cold ablation, as I will tell you in a moment, can be used with any material. But okay, this is only cutting. Of course, femtosecond lasers, they are much more useful and they can serve in more application than just cutting, because you can also structure your material doing some black marking or hydrophobic structures, like you can see on those two pictures here. And you can also do laser-induced periodic structures, like you can see here, lips. And you can do in-volume marking, you can do glass welding, and much more. I mean, here I just tell you a little bit about cold ablation, that this is a fantastic method of cutting different materials, because you can cut with lasers, many lasers available. You can cut with CW, you can cut with nanoseconds and femtoseconds, and of course, you obtain different results. So here you can see some comparison between nanosecond laser and femtosecond laser, and the quality of those two methods. So after processing, you can see this, the sample process with femtosecond laser is much better. And the reason being is that femtosecond laser, they have much shorter pulse, much higher peak power. So in effect, you can ablate the material and the sample doesn't have enough time to heat. So this heat affected zone is much smaller, and you can do the ablation in more precise way, and you can focus the beam very, very, very well, not causing the damage to the surrounding material. And this is one thing that we do in our, for example, newly opened application lab in Wrocław. And if you have femtosecond laser, that help. If you have femtosecond lasers with great parameters, it's even better, because then you can obtain bigger efficiencies, bigger speeds. And this is we demonstrated very recently. We obtained a record high ablation rate of glass with this value on the screen you see here, 0.85 millimeter cubic per minute per watt of our laser, where the laser source was our Jasper laser. But like I said, ablation is great because it's not only limited to glass. You can do all parameters. You can process all different materials, from semiconductor through sapphire, diamonds, tungsten, titanium, polymers, and much more. You can even operate. You can even work with live tissue to limit this heat affected zone, not to damage the tissue, but to work and process this tissue. It's very ultra interesting. Just a couple of words about our laser that we use for this microprocessing and micromachining. So the best choice right now we have is Jasper XO. So this is a femtosecond laser that comes in 4 power variants, and you can have either between 10 and 60 watts of average power and 100 microjoules of pulse energy, even bigger energy in a burst mode. And what's most attractive is that you have one laser where you can have both femtosecond pulses and picosecond pulses, and this spans over like a very broad range from 250 femtoseconds up to 20 picoseconds. And not only that, because you can also tune with repetition rate from single pulse to 20 megahertz. So this gives you like a broad range of parameters that you can change. You can match the parameters to change your parameters to match your process, to match your material. And for example, for glass processing, it might be longer pulse that is more effective. And for some metals, it will be shorter pulse of 200 femtoseconds. That's the most precise and best for the application. And these parameters, together with the fiber construction of the laser, brings you the advantage of being able to not only doing it efficiently, but also you are provided with a reliable and robust system for your lab or for your factory. So this pictures here, these graphs here are to show you how you can use the power inside these different power variants. So having this 10-watt laser, you can operate 10 watt at full repetition rate of 20 megahertz, and the energy, of course, also change with the power. What's amazing about this Jasper laser is not only what I have already mentioned, but also that you are provided, you can be provided with additional module, harmonic generation module, that provides you all 4 wavelengths. So with one laser, you can have both IR, you can have green, UV, deep UV outputs, and you can use software to change the wavelength within seconds. And this is all configurable. You can select what wavelengths you need, and also having all 4 is very useful if you do prototyping, you have different materials, because then you can select one wavelength that works best for your application. So this is a very versatile solution, like I said, and having this short pulse duration, like I said, we specify under 250 femtoseconds. Actual pulse duration is even better, and this brings big advantage in micromachining. So there's a big difference whether you use like 600 femtoseconds or 200 femtoseconds. It's make a big difference for many materials. So it's best to be flexible, so you can select whatever pulse duration you actually need. Okay, so I just wanted to mention to you that there's also in our offer Jasper Flex, which is a very similar laser, it's just smaller in size. So if you don't need a lot of energy, you still want to have significant laser power, this is the laser for you, right? So you can operate at this full energy of 30 microjoules, even at 1 megahertz. So you can have many pulses within the same time, which enhance your processing times and enhance your micromachining. And it is worth mentioning that for many applications, you don't actually need a lot of energy. That's actually high fluence at some point is more problematic. So it's better to have lower energy and more pulses in order to increase your efficiency, increase your speeds. And this is just a couple of examples of what we do at Fluence, what applications we do. So something like I already mentioned, semiconductor scribing, glass cutting, but also selective layer removal, like gold from silica, biopolymer cutting, some metal cutting in general, very precise pieces, and structuring of the materials like hydrophobic structures, black marking, and some color effects like you can see here. So this is all very interesting. This is all that we do at Fluence. We are very happy if we can work with different customers with different applications. So if you have any requirement, just get in touch with us. You can drop an email to our address over here. You can visit our website. You can meet us in live in at this Photonics Plus exhibition. And well, thank you very much for your attention.